While conventional ground plot-based forest inventories produce attributes over very large areas, Tesera Systems' high-resolution inventory solutions deliver more accurate estimates of forest attributes at a much finer scale. This finer level of detail provides a fully scalable inventory that enables more detailed analysis, improved decision-making, and the accurate quantification of attributes over diverse forest conditions. So, how much more accurate are our high-resolution inventory solutions? In this short overview, we will quantify the accuracy of HRIS over a conventional ground plot-based inventory. Over multiple projects in diverse forest conditions, HRIS is more accurate, with an increase in predictive accuracy of 66%, or 3 times as accurate. This means that in order to achieve the same accuracy with a conventional ground plot-based approach, one would need to establish at least 9 times the number of ground plots. We will begin by describing the datasets used for developing an HRIS inventory. Then, we provide a brief explanation of how HRIS is constructed and explain our comparison methodology. Finally, we will share the benefits of a more accurate inventory at a higher resolution. HRIS typically uses 3 data sources: ground plots, LiDAR, and remotely sensed data, such as multispectral high-resolution satellite imagery. HRIS develops models for each target attribute based on the plot data and from approximately 1,300 machine learning features derived from remote sensing data. For each attribute, we select a subset of the features that is best at explaining the variation in the plot data. This feature selection is combined with cross-validation to protect against overfitting. Once a model has been selected and fitted, it can be used to predict the value of the attribute over the entire project area. The accuracy of the inventory is therefore a function of the predictive accuracy of our models. A common metric for measuring the predictive accuracy of a model is the root mean squared error, RMSE. For each ground plot, we want to compare the actual observed value with the prediction produced by the model. The lower the RMSE value, the better the accuracy of the model. And since the RMSE value is on the same scale as the forest attribute, such as trees per hectare, we can easily determine whether the accuracy is within the operational tolerance limits desired by our clients. As part of our analytical process, we compute RMSE values by using cross-validation. We randomly split the dataset into subgroups, and one at a time, one subgroup is put aside for testing. This approach ensures the predictive accuracy is unbiased and prevents overfitting. For a conventional ground plot-based forest inventory, the goal is to make inferences at a coarse scale for specific strata across a project's area of interest. For an HRIS inventory, we increase the accuracy of the predictions at a much finer scale. We do this by segmenting the project area into analysis units of about 1/25 of a hectare, or about the same size as the ground plots. Forest attribute predictions are applied across all these analysis units. The analysis units are then rolled up into reporting units of approximately 1/5 of a hectare. Further aggregation is also possible, depending on our client's needs. So, let's compare the RMSE values for a conventional, stratified ground plot-based forest inventory versus an HRIS inventory. Over multiple projects across diverse forest conditions, the HRIS inventory is more accurate, with an increase in predictive accuracy of 66%, or 3 times as accurate. This means that in order to achieve the same accuracy with a conventional ground plot-based approach, one would need to establish at least 9 times the number of ground plots. Tesera's more accurate and scalable inventory brings numerous benefits, including knowing the precise quantity and distribution of tree species allows for better planning and margins from logging operations, ensuring that forests are harvested at sustainable rates. And accurate inventories also help identify biodiversity hotspots and endangered species, enabling better protection and conservation efforts. And with accurate data on tree biomass, it is easier to estimate carbon sequestration capacity, which is crucial for climate change mitigation and carbon offset markets. These are only a few of the benefits of an accurate forest inventory. Our high-resolution inventory solutions are accurate, scalable, and cost-effective, offering both enhanced forest inventory and individual tree inventory capabilities. If you want more details about this comparison or HRIS in general, let's connect. Let's chat. Schedule a live demo. How can we help enable your team, project, or opportunity?